Now, so to obtain this value is 2e 2 times 0.5 plus 6 times 0.5 minus 2 times e 2 times 0.4 minus 6 times 0.4. Okay, you work it out, you will get this actually 2e minus 2e 0.8, then you got this 3 minus 2.4. Okay, by working out using a calculator, you will get the answer that's required. Okay, this is for this case. Okay, now why this question is picked, because this is show you that if without a turning point here, that means the velocity go in the opposite direction, so you can just take whatever limit that is set, you just integrate the velocity function, you will get the distance traveled during the period t from when it's traveled from 0 t equal to 0.5 to 0.4 to 0.5. Okay, now let's talk about the earlier one. The earlier one is v equal to, the previous question is 4t square minus 8t plus 3. Okay, so this is the earlier lost the question when v equal to 0, so 4t square minus 8t plus 3, which we have done earlier in the video. Then we get t equal to half, and also or t equal to 3 over 2. Okay, now let's plot this. Now you look at the v here, you put v here, this t here, you notice that this is a minimum curve, and when v goes to the mean, the x-intercept is half here, and 3 over 2. Okay, now and then the y-intercept is 3, so you sketch this. Okay, now here there's something very interesting here. You look at the velocity before t equal to half is actually a positive value. Okay, by the time it cross t equal to half, the velocity becomes negative, means the particle's direction have changed. Okay, you go in the opposite direction. Then as you travel along here in the opposite direction, when you reach a certain point, the velocity become positive again. That means you make a reverse. Okay, if you look at this, okay, look at the number line here. Let's say this is O. That means let's say this is t equals 0. T equals 0 is at this position. So the particles travel from here until t equal to half. Okay, this S. So t equal to half. Okay, at this point, remember, at this point here, when you go further, it becomes negative. That means to say the object actually travel backwards. Okay, then by the time you reach time t equal to 3/2, then from here become positive again, then you travel this direction again. You see that? Okay, so it's very complicated compared with this, where there is no turning point. So it's just straight. You just integrate the velocity function with respect to time, okay, and then put in the two limits of the time, then you get answer. But for this case is different because of the turning back. Okay, so now one of the very important thing is when t equal to 1.5, where is the position of the particles? That means if you integrate this velocity, you get a s function. Okay, the s function with respect with time is a t. Okay, now this s distance is dependent on the time. Okay, so if you substitute after you do the integration, you got an s function. S function s equal to a function of time. Okay, now so we know from 0 to t equal to half, if you substitute s t equal to 0.5, you will get a distance of 2/3. But before that, you must integrate to get the s function. Okay, now then if you substitute t equal to 0.5, you will find out this distance is actually 2/3. Okay, now when you reach this point, you make a turn back. Y become, from here we know it become negative after t. So by the time you reach t equal to 3/2, okay, you make a turn again in a positive direction. Here velocity is positive. Now we have to locate the position when t equal to 3/2. Okay, so again you substitute t equal to 1.5, 3/2. You notice that this is equal to 0. It means when t equal to 3/2, the object just at the O position. Okay, at the O position. The object is at the O position. Now, that means is at the starting position lah. Okay. Now the interesting part is the distance from here to here. The distance gained from t equal to 0 until t equal to half is 2/3, and then the distance gained from t equal to half to 3/2 is equal length. You can see here, from here to here is equal to from here to here. So this distance is also 2/3. Okay, so if you want to find the distance from t equal to 0 all the way until t equal to 3/2, then you take 2/3, which is from here to here, times 2. Okay, so the final answer here, the distance is equal to 2/3 times 2, from 4/3 meter. Okay, so this part here, where there is a turning point between the time period that you're supposed to find out the distance, check whether is there a turning point. If no turning point like this case, then just do the normal integration, put in the two time limit, you get the answer. Okay, but if there is a turning point here, from time period from here to here, there's a turning point, then you have to break down the distance, segregate them into two separate distance and found them individually, then only add together.